Assalamualaikum and a very good evening to all. My name Muhamad Talhah bin Tambikha. I'm a final year student for Bachelor of Mechanical Engineering from UiTM Shah Alam. First of all, I'm deeply thankful to my supervisor, Dr. Noor Azlina Muhammad Salleh, for her guidance and support me. Besides her guidance, I will not able to finish my project. So today, I would like to present my FYP entitled Augmented Reality Karakuri Sop. Okay, now the background study of project. This study is focusing in developing the mobile application with the main content of 5 basic Karakuri models and make it to live view with true experience by implementing the AR technology. Many industries are putting effort in implementing the IR 4.0, but at the same time are facing various challenges such as lack skill and knowledge. So, the AR technology and Karakuri system are solutions to overcome this challenge. What is augmented reality? Augmented reality is the true physical world technology accomplished by digital graphics such as visual, sound element, or other sensory input which are created by an advanced software. For the figure besides, we can see the 3D model pop out from the picture they had scanned. Okay, AR can be found on various electronic devices such as mobile, desktop, and HoloLens. AR technology can be described as simulated 3D model superimposed on real 3D environment. What is Karakuri system? Karakuri system represents pure mechanical device that increase work efficiency without external source like electricity. It can be defined as mechanism device that only rely on physical force rather than electrical power supply. Here the video show how the Karakuri system work in industry. There are 5 basic Karakuri models which are seesaw, pulley, slide stroke, slider crank, and rotation. These 5 models can reduce the 3M issues in lean production known as mudah or waste, muri or overburden, and murah or uneven. Now the objective of this project. The first one is to study the Karakuri system and AR in field of engineering, to design and animate the 5 basic Karakuri models by using CATIA software and Blender software, and the last one to display the assembly process of 5 basic Karakuri models by using Unity Hub software. Software and tools that I have been used. First, CATIA V5 to design the 3D models. Second, Blender software to animate the 3D models. Third, the Unity Hub software to develop the AR technology. And the fourth, Microsoft Visual software for coding and scripting. Number 5, laptop or desktop work as main operating system. And number 6, Vuforia SDK kit tools to create image target. Number 7, Android SDK kit tools to develop the apps in Android device. And the last software or tools we have been used is Android device main platform to run the apps. Okay, now the project activities during my whole semester. Firstly, the modeling phase. The modeling of 5 basic models of Karakuri system had been designed by using CATIA V5 software. In modeling phase, every type of Karakuri mechanism had different parameters and dimensions that need to be designed with accurate and precious. The standard catalog that had been provided and show the exact dimension, type of materials, and weight of parts. Okay, here we can see the 3 examples of catalogs that I have been referred for modeling my models. Okay, here my 5 basic mechanism that I have been designed in CATIA V5. Okay, the second phase, animation phase. The animation phase had been done in Blender software. The timeline was the place where the animation took place by edit the keyframes. Keyframe was an editor tool which allowed to store data about the bounds in rig and store the information about the scale, rotation, and position of each mechanism. By changing this value, and animation can be created with properly and smoothly. Video besides show the video reference that I have been used for modeling my models. Okay, here the picture during my animation by using Blender software. Okay, the third phase, the development of AR phase. The first one, create the image target. The image target can be any type of picture and must be in format JPEG or PNG. Drag the 3D model into main scene and place it on top of image target. When the image target was detected by phone camera, the augmented models will pop out and be visualized on the screen. Second, add multiply scene. The scene can be added by clicking the file section on top of the screen and choose new scene. The new scene works as layer screen in mobile application. For example, main menu screen, credit screen, introduction screen. Okay, the third one is add the button features. Right click on the hierarchy section and choose the UI and find the button. In order to give this button a specific function, C# scripting need to be added into the button inspector components. The button can have multiple functions. For example, start an animation of models, changing screen, or play the video or audio player. Number 4, add the animator controller. Allow to arrange and maintain multiple set of animation for the model. For example, the assembly process for each mechanism will consist of several clips, so the sequence of the clips must be in order from step 1 until the final step. The transition of this animation can be controlled by adding the C# script into the mechanism. And number 5, write the coding script. Multiply features and system during the development of AR were quite tricky and tedious. Function of scripting is to deliver the programming input into the features in application and create the event as what had been said. The language had been used in Unity is C# language. And lastly, run the apps on Android device. Click the build setting section in Unity Hub software and set the Android as the default platform. Transfer the APK file to the Android device. Okay, there are 4 steps how to run the apps. First, download and install the APK file. Open and run the application, pointing the camera into the image target. And the last one, the 3D model will pop out on the screen. Okay, the result findings for my project. Okay, for here I will provide a video in real life which I install on my Android device. Okay, here my application I install in Android. Okay, we click the icon FYPAR. Okay, here the loading screen before we enter. Once we enter, okay, here my main screen of application. This screen as a main screen, there is 2 buttons. We click the enter on bottom right. Then here we got 3 buttons after we click the enter buttons. Okay, here I've shown the credit screen. When we click the button of credit, this screen will pop out. It show my name, my supervisor, and my others info details. Okay, we click the button back on the top side right. Okay, here for the introduction screen, which I provide information about the image target. This QR code work as image target or tracker. The users can download my image target, this application image target, by clicking the catalog. Then it can bring to the Google Drive and the users can print and on A4 paper. Okay, we're back. Now we enter the start button. Okay, here I provide some encyclopedia for augmented reality and Karakuri system. Okay, here I click the augmented reality.
Next up is AR. Augmented reality is a technology
here
that
it shows the
projects
videos
computer-generated
and the
augmentations on top
encyclopedia
reality.
of augmented
Continuous
reality.
perform-
Okay, we back, and now the Karakuri system. We click the text and we scan the QR code. The video about the Karakuri system will pop up, and the encyclopedia. Okay, next we enter the main content, the 5 basic mechanism. We click this, and here I provide 5 basic mechanism model. You can see by scroll down 1 until 5. I also provide some notes for users, and we can click this to see the picture of combining mechanism. Okay, we click the model. Okay, for this one we click the seesaw model. Firstly, here I provide 3 options for each model. We got 3D model, assembly process, and animation for each of model mechanism. Okay, we click the 3D model. Please scan the QR code. When the user scan the QR code, the 3D model of seesaw will pop out. The users can rotate, scale, and move the model. Okay, then we back and we see the assembly process. Okay, here there are 7 steps for assembling the seesaw mechanism. Here also I provide some catalog for what component or what tools have been used for developing the mechanism. Okay, we click the first button. When we click the first step, the assembling of the seesaw will start, and they will produce some music, which means this process is undergoing. When the music is stopped, it means each process is in and ready to go for next assembly. Okay, we wait for this. Okay, now
End process 1.
the music is stopped. We proceed to the second step. Okay, the components will come and building the mechanism. Okay, you can see here there are 7 steps, but for the step 3 until step 7 I will fast forward. I will show the time lapse for the process. Okay, we wait for the step 2 to end. There's still some components to come.
End process 2.
Okay, now this I'm fast forward for step 3 until the step 7, because it required a lot of time for waiting and see the models. You can install my application and ask me for the APK file and try it on your own. Okay, here I show the example only for my each model. Okay, the 7th step, the last step. Okay, I show from step 1 until step 7. So the seesaw mechanism have completely developed.
End process 7. Complete all assembly process of seesaw.
Okay, then we click back button. We check the animation of this mechanism in real world prototype. Okay, same like usual, we scan the QR code. When we scan the QR code, the simulation or the animation how this seesaw will work in real prototype. Okay. Okay, we back and we check for the other model. Second, we check the pulley mechanism. We click the 3D. We want to see the 3D model of pulley mechanism. Okay, here the 3D model of pulley mechanism. Okay, we back and we see how to assembly this pulley mechanism. For this, there are only 6 process in total. Okay, here also I provide some catalog for users to see what component had been used. Okay, here I'm fast forward for step 1 to step 6 because it required a lot of time to see from the step 1 to step 6. Okay, here the animation of the pulley, how it works. Okay, here the simulation. We push and the other side will go up and the other side will go bottom. Okay, we check for the third model, the slide stroke, the slide stroke mechanism. Okay, same like usual, we scan to see the 3D model, which is static model, it's not moving. Okay, we check the assembly process, how to assembly. Okay, this mechanism required 6 steps. Okay, here same, I fast forward the process just to see the functionable of this application. Okay, we see the animation for this mechanism. Okay, this is how it works in real prototype. Okay, we go back and we check the fourth mechanism, the slider crane. Okay, we check the 3D model. Okay, the static model. All this design are designed by refer to catalog in CATIA V5. Okay, we check the assembly process. This is the longest process. There is 8 required step. Okay, I fast forward. Okay, so that's how it building. Okay, now the animation of this mechanism. Okay, we pull the handle and the other part will go up and down, will go forward and backward. Okay, for the last model, rotation, same like usual, we can check the 3D model. Okay, then you can move around and scale up and down. And now the assembly process, it's only required 5 process for building this mechanism. I fast forward. Okay, now the last one, we check the animation, how this rotation mechanism works. Okay, so it will rotate in up 360 clockwise and anti-clockwise. Okay, so that's all for my application. Okay, now the conclusion of my project. This application needs many improvements yet, especially in terms of user interface. Fortunately, while doing the demo test, many users have given positive feedbacks and comments due to its content and interesting features. Lastly, there will be improvement in user-friendly, which the application can run in multiple platforms such as iOS device, desktop, console, and virtual extended reality platform like HoloLens. Okay, that's all from me. Thanks for watching my video. My name Muhamad Talhah bin Tambikha. I am final year student and this is my project, Augmented Reality Karakuri Sop. You can contact me on phone or email me like the information I had given, and also can inform me to us if you want install my application. Thank you.